Lesson 3, topic, triangle congruence by side angle side and hypotenuse leg. Learning target, I can prove triangles are congruent using side lengths and angle measures. First, we're going to talk about side angle side congruence postulate, which is abbreviated SAS. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So what included angle means is that it's between the two sides that are congruent. So those two sides that are congruent make up the sides of the angle. So we have the angle here and then the two sides. And we're going to talk about the reason why it only works that way in a bit. But so we have side, then angle, side, and we can say that the two triangles are congruent. Let's practice. Decide whether enough information is given to prove that the triangles are congruent using the side angle side congruence postulate. So we look at our two triangles here, ABD and CDB. We can look and we can say, okay, we have side here, and our angle is all the way over here. So the only other side that they would have congruent is BD because they share it. So if you look, it would need to be this angle and this angle congruent to each other to be that included angle. Because if we look at what we have right now, we have side, side, angle. So if we spell that out, side, side, angle, read that backwards. We are not donkeys in math class, so we don't use side, side, angle. So it has to be side, angle, side. And we'll talk about the reason why for that coming up soon, but we don't have enough for side, angle, side, so no, we don't have enough information. And then for our second example, we have LMN. So we have side, angle, side. We have side, angle, side on triangle NQP. So yes, we do have enough information by side, angle, side. So now let's do a proof here. We have write a proof given that side BC is congruent to side DA and side BC is parallel to side AD. Prove that triangle ABC is congruent to triangle CDA. So I have the proof set up for us. We've got our givens in the proof already and what we need to prove. So if we're looking at doing side, angle, side, we have side. This is one of our sides that is congruent to each other. Angle, well, this isn't an angle, it's parallel. So number 3 will be our angle and number 4 will be our side. So then we can say that these are congruent by side, angle, side, congruence postulate. Let's make sure we have enough information. So we know that BC is parallel to AD, so we're going to have to go back to what we learned in Unit 3 about parallel lines cut by a transversal. So if we have parallel lines cut by a transversal, we have some alternate interior angles. So we know that this angle would be congruent to this angle, and this angle would be congruent to this angle because we have alternate interior angles. So what we need to do is we need to figure out which angle pair is going to be helpful for us with side, angle, side. I'm going to clear this. So we have to look for that other side that's congruent to. We have no information about BA being congruent to CD, but we do know that they share side CA. So for that side piece, it's going to be CA is congruent to CA by that reflexive property. So now we know side and side, we can get that included angle by figuring out which angle is included in our two sides, and that would be this angle right here and this angle right here. So it would be angle BCA is congruent to angle DAC by alternate interior angles theorem. So now we have shown that two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle. So we can say our two triangles are congruent by the side angle side congruence postulate. All right, so now we're going to talk about our next one, hypotenuse leg congruence theorem. And this is a special case theorem because as we talked about, we don't use side-side angle because again, read it backwards. We're not donkeys in math class. And the reason why is if you look up here, we have two triangles that are congruent. So we have this side is congruent to this side. So there's your side piece. This side is congruent to this side, so second side. And then we have the angle congruent to the other angle. But if you look at the two triangles, you can tell by their appearance they are definitely not congruent triangles. So that's why side-side angle does not work as a congruence theorem, because you can have triangles with two congruent sides and an angle that's not included in those sides congruent, and the triangles won't be congruent, so it doesn't work out. Except for when we have a right triangle. So we call it hypotenuse leg because we have special names for our sides in right triangles. So as you can see, the hypotenuse would be one side, the leg would be the other side, and then the 90-degree angle is the angle, but we just call it hypotenuse leg because when we use the word hypotenuse, we know we are dealing with a right triangle. So as long as the hypotenuse of one triangle is congruent to the other one, and the leg of one triangle is congruent to the leg of the other, we have congruent triangles. So now let's use hypotenuse leg in a proof. I've done some of the proof for you, so I just want us to complete the proof. So we are given that WY is congruent to XZ, right here, WY congruent to XZ. So that would be the hypotenuse of those triangles, because you can see, hopefully those are going to be right angles. We're not told that just yet, but that would be the assumption. So let's keep going. WZ is perpendicular to ZY. Well, yes, WZ perpendicular to ZY. That means they're going to make that 90-degree angle. Perfect. XY is perpendicular to ZY. So you have the XY perpendicular to ZY. That's going to make that 90-degree angle. We're off to a great start. So we want to prove that WYZ is congruent to XZY. So right now we have our givens. So I know that this piece is that hypotenuse for the hypotenuse leg. This piece is giving me that right angle information. And then we just need that leg piece. So we need to know where our leg is. Now, if you look up at our diagram, it's like really messy. And so whenever I have overlapping triangles, I always like to redraw my picture into two separate triangles. Just move things around, rotate things, make it nice and easy for me to read. So now I'm going to remark this. So we have this is congruent to this. We have those right angles. And also, now I can clear this diagram so I can see that they share a side, right? They both share ZY. So I can say that this leg is congruent to this leg by that reflexive property of congruence. So ZY is congruent to ZY. And now we just need to write out the fact that, hey, we have some right angles. We have right triangles. So I'm going to say angle WZY is, the measure of angle WZY equals 90 degrees. And that's that definition of perpendicular. And then again, the measure of angle XYZ equals 90 degrees by that definition of perpendicular. Now that we know we have right triangles, we can say, hey, these guys are congruent by hypotenuse leg congruence theorem. Again, apologies for the longer video. Hopefully this was helpful to you and you can move right on into your practice.